Have you ever looked up at the night sky and wondered what lies beyond the stars? Somewhere far past every planet, every nebula, every lonely sun, there's a place humans have whispered about for generations. The Andromeda Galaxy, our massive swirling neighbor, and someday, the galaxy we will collide with. Tonight, we're going on a journey. Not with rockets or engines, but with imagination, time, and the cold mathematics of the universe. Because the question sounds simple. How long would it take to reach Andromeda? The answer is far from simple. Andromeda isn't just out there. It's far beyond anything the human brain evolved to understand. The current estimate puts it at about 2.5 million light-years away. People hear light year and think of something exotic. But let's make it real. A light year isn't time, it's distance. The distance light travels in 1 year. And light moves at 300,000 kilometers per second.
So imagine light, the fastest thing in the universe, the absolute speed limit of existence. Even traveling at that speed, it would take 2.5 million years to reach Andromeda. Pause for a moment. Take a breath. Let that sink in. That means if you left Earth during the early Stone Age, your spacecraft would still be traveling today. You wouldn't even be close. That's the scale we're dealing with. But light is theoretical. What about us? What about the fastest thing humans have ever built? That title goes to the Parker Solar Probe, traveling at around 700,000 kilometers per hour. Incredible, record-breaking, a masterpiece of engineering, and completely useless for intergalactic travel. At Parker's speed, reaching Andromeda would take about 4.4 billion years. Billion with a B. By that time, Earth would be unrecognizable, the sun would be dying, and humanity, if it even still existed, would be something entirely different. The fastest ship we've ever made is basically frozen in place on a cosmic scale. Space isn't big. Space is unimaginable. Our technology doesn't just fail to reach the scale of the universe, it isn't even close. But let's be generous. Let's imagine humans unlock propulsion methods far beyond anything we can build today. What would it take then? Suppose we build nuclear fusion engines, ships powered by the same reaction that fuels the sun. A realistic top speed might be 10% of the speed of light. Even at that incredible velocity, the trip would still take about 25 million years. Faster, yes, but still impossible on human timescales. Now, let's get even more futuristic. Antimatter engines. Insanely efficient, unimaginably powerful. Optimistic estimates put them at maybe 50% the speed of light. At half the speed of light, you still need 5 million years to reach Andromeda. Faster again, but still unachievable for any civilization with a lifespan measured in centuries. And here's the kicker. Even if you somehow reached 99% the speed of light, even if the crew experienced only a few decades of time thanks to relativity, the outside universe would still see millions of years pass. You could reach Andromeda, yes, but humanity back home would be ancient history. You would arrive in a galaxy that no longer remembers you. So is reaching Andromeda impossible? Not exactly. There are wild, speculative ideas. Shortcuts through space-time itself. Wormholes are one example. A tunnel that connects two distant points in the universe. Enter one end, exit the other. If stable wormholes exist, and that's a massive if, you could reach Andromeda in seconds. But right now, we have no proof they can exist, no idea how to build them, and every physical model says they collapse instantly. They belong more to science fiction than engineering. Then there's the Alcubierre warp drive, a real hypothesis in real physics. Not faster than light travel, but bending space-time itself, compressing space in front of you and expanding it behind you. You aren't breaking physics, you're riding physics. In theory, with a warp bubble, distance becomes irrelevant. You could go anywhere, including Andromeda. But the energy required is beyond anything humans can produce. Some versions even require negative energy or exotic matter, things we don't know how to create at all. So for now, the hard truth is this: humanity will never reach Andromeda with technology even remotely close to what we have today. Not because we're not smart enough or ambitious enough, but because the universe is simply too big. We are tiny creatures living for tiny spans of time, trying to measure distances meant for gods and galaxies.
But here's the beautiful poetic twist. We don't have to go to Andromeda. Because one day, Andromeda is coming to us. Right now, the Milky Way and Andromeda are moving toward each other at roughly 110 kilometers per second. In about 4 billion years, the two galaxies will collide in a slow, dramatic dance across millions of years. Stars will rarely crash into each other, there's too much empty space, but the gravitational chaos will reshape everything. The end result? A brand new galaxy, a cosmic rebirth. Astronomers already have a name for it: Milkdromeda. Humanity won't be here to witness it, but the universe will. And in a way, we're part of that future whether we like it or not. So how long does it take to reach Andromeda? Longer than civilizations survive, longer than stars live, longer than the Earth will exist. And that's okay, because the point isn't to go there. The point is to understand our place in this vast, impossible universe, to recognize how small we are, how fragile we are, and how miraculous it is that we can look up, think about galaxies millions of light years away, and ask questions like this at all. If you enjoyed this journey, make sure to like the video, subscribe for more cosmic stories, and let me know in the comments, what galaxy should we visit next? Until then, keep looking up. The universe is waiting.